Yeah, watch. So let's have a set that consists of 3 elements, A, B, C. A, B, C. Now, a table, a binary operation table, gives you all the results, or gives you the results, or the result, for each possible ordered pair. Right? So let's, let me generically write down these 3 elements as AI. So, for example, A1 would be A, A2 would be B, A3 would be C, let's say. Okay? So, for all possible ordered pairs, binary operations on them would be something like this. AI, binary operator, IJ. Okay? Now, I can be 1, 2, or 3. J can be 1, 2, or 3. So how many possible, total ordered pairs will we have? Well, there will be 9, right? Because 3 possibilities here, 3 possibilities there. So we have 9 possible ordered pairs. 9. Now, so let's call a particular one, you say one of these 3, let's call it just AI. And similarly along the row here, one of these 3, let's just call it AJ. So here, in the table, here we will put AI operator AJ. Okay, we'll put it here. So, so if you do A operator A, let's say you get B. So I'm just writing this out. So if you do A operator B, you'll get C. So A operator C gives you A. So B, A, note the order. So I'm taking one of the column elements and binary operating with one of the row elements. So so BA. So this will be. So this will here will be B binary operator A. And from the table it's actually B. Now here it'll be BB. That gives me an A. And BC gives me a C. And C binary operator A gives a C. C binary operator B gives a B. Yeah, just say. I mean, this is just given. There's no like rule or anything. C just gives you C. Now, if you're given a binary operation table like this, then you know everything about the binary operation. The whole knowledge of the binary operation is in the table, because the table is complete. Now, have a look at this table. Is it a binary operation? Does it satisfy both of these 2 criteria? One is that there's one and only one result, right? Well, here's 1 and 1, 1, 1, 1, 1. So that's okay. So this condition is met. And the second condition for the binary operation to be a binary operation is that the result, C here, has to belong to the set. Well, these are all the results, right? So AA gives you B, and AB gives you C, and AC gives you A, and so on. All of these belong to the set. Remember, the set is A or B or C. Okay. So both are met. There's one and only one result each time, and each result belongs to the set, because the set is A, B, and C. So that binary operation on that set is a well-defined, and it is a binary operation, okay, according to these two criteria. One and only one result, and the result must belong to the set. Okay. All right. Let's actually do one a little bit more concrete. This is rather a bit abstract. So again, I'll give myself some space if I can find the rubber. So let's actually construct a table to give you a feel for how it's done. All right. So you need to start. You need to have two things. You need to have your set S that you're starting with, and here it is. We're going to construct a binary operation table. Right? Now, in 2 weeks' time, this table that, in fact. I'm jumping ahead a little bit, but the actual table that I'll construct right now is in fact a group. So in 2 lectures' time, we will stop calling this table a binary operations table, and if we're talking about a group, we'll just simply talk about the group table. So let's actually construct a table. So you start with your set. And the set consists of 4 integers, 2, 4, 6, 8. That's your set, okay? And the binary operator, by definition, so 3 bars by definition, is so A operator B is defined as the product. You just multiply these 2 numbers and then mod them by 10. Remember from a previous lecture, to mod, what does that mean? Mod is short for modulus. Modulus. And what's the modulus? The modulus is the result after you, the remainder, what's left over after you do a division. So, for example, 24 mod 10 would be 4, right? Because 4 is left over when you divide through by 10. 7 mod 4 would be 3, right? Because you get the remainder is 3. Okay, well let's fill in the table. So we put the elements of the set in the column on the left, and the same elements of the set, usually in the same order, in the row at the top. So 2, 4, 6, 8, 2, 4, 6, 8. Right? Now, you multiply 2 elements and then divide by 10, get the remainder, what's left over, and put it in the table. That's the idea. Okay, well I'll do this fairly quickly. We have 16 cases to do. Okay, 2 2's 4, mod 10, well that's just 4, right? 2 4's are 8, mod 10, that's just 8. Now 2 6's are 12, mod 10, that's 2. Okay, and 2 8's are 16, mod 10, that's 6. Okay, now I'll go a bit faster now. 2 4, that's 8. 4 4's are 16, mod, that's 6. 24, so that's 4. And 4 8's are 32, mod 10, so that's 2. Okay, 2 6 12, that's 2. 6 and 4, 24, so mod gives you 4. 6, 6 is 36, mod 10, so that gives you 6. 6, 8 are 48, mod 10, that gives you an 8. 8 to 16, mod gives you 6. 48, 32 gives you 2. 48, mod gives you 8, and 8, 64. Okay? Alright, there is a table, a binary operations table. And in fact, it's actually a group. So